You sat beside me.
Nice to meet you.
Okay.
You're welcome.
Yeah, we were just thinking out right now.
No. I think this is everybody. Yeah, I think this is everybody.
We're all saying hi to. Chair-wise, not person.
All right, so welcome to Introduction to R. Took like a lot of emails and a lot of stuff to kind of get this thing off the ground, so glad we could do it and you all can make it. So I'm just going to go through a little bit about myself, class overview, and we're going to get kind of everybody up and running. Everyone should have received an email from me kind of saying like, this is where you download R, this is where you download RStudio, and these are two other things. So the first modules that I think are really good are Try R from Code School, and Data Camp has a module called Getting Started with R. So they're two really good first pass interfaces so that you don't have to download anything, you can do everything online. So if you are going to train anyone else in your group, for example, I think they're really good, introductions. They do really, in-depth discussions about what you're doing, what you're typing in there. You don't have to have anything downloaded off the bat. You do have to have a laptop for the class. A few years ago, we did have someone try to do this on an iPad, and it just didn't work out. So R runs on a lot of things, so Mac, Linux, and Mac, Linux, and Windows. But it doesn't really work on your phone or that other stuff. I don't know why you'd be trying to do that, but some people have. So my name is John Michelli. I'm an assistant scientist down at the Department of Biostat. So I got my PhD and my master's here. So I've been here for a long time. So I've been here for almost 9 years now. And I worked in the consulting center 2 years in between. So I've been using R the entire time. So I've been almost using R for about a decade. So some of the things I'm going to teach you are not the way that I necessarily learned R, for better or for worse. So if you do talk to someone who's a longtime R user and you show them your code, it might look a little bit different than their code. The reason we teach it this way is because there's a lot of developments that happened in the last 5 years. A lot of developments happened in the last 2 years that make things a lot more intuitive for an R user. And there's a lot of reasons for that. I will say, after teaching this course 2 weeks ago, it is not Stata, it is not SAS. We will talk about that over and over again because I think Wednesday, I feel the class gets really like, oh, I can do this, I can do this. Why can't you do this? Stata can do this. Why can't you do this? SAS can do this. Or it doesn't do this the same way in SAS. And I say no. That's because it's not SAS. We will talk about some of the intricacies, but if you do have any questions, say, I know how to do this in SAS, or I know how to do this in Stata, I want to know how to do it in R. I'll be happy to try to give you an example of that, whether real time or after I'll do it the next day. All right, so what is R? So it's a language and environment for, it was originally started for statistical computing and graphics. So that's why a lot of people are drawn to R. They say, oh, the graphics are really nice. And that's true, but like any other language, to kind of get a publishable figure, it takes a lot of time, a lot of energy, a lot of tweaks, a lot of label changes, all that kind of stuff. But it's really grown out of that. You can do a lot of different things. So it's kind of like this weird hybrid. So people that come from computer science say it's not a real language because it kind of has these like weird quirks that computer science people don't really like. Like people in Python, you can do things one way. R, you can do it like 10 different ways. Some are better, some are worse. So it is a little bit daunting kind of to a new user. We're going to try to keep it relatively constrained during the course. Say, this is the way we're going to teach it. You can do it these other ways, but this is the way you're going to do it. It started off as a language called S out of Bell Labs. This was before the time of Google, before you made a language that might be easier to Google than the letter R. That being said, it has gotten better, and we'll talk about a few ways to Google for answers in R that kind of bring things to the top that might not be too hard. So it's open source and open development. So it's built by a community of people. So it started out at Bell Labs, but a group called the R Core actually still write the main language and maintain that. So some people get paid for that, some people really don't, but it's not like they're funded by an overall organization like SAS or Stata. They're not necessarily a company. We will talk about RStudio in a minute, and that is a company, but it's separate. So kind of why do people use R? It's powerful and flexible. It can do a lot of things. It can customize plots and tables and that kind of stuff to almost any way you want it to do. Not always the most simplest way, but I will say working in Stata for a few years, a lot easier than getting out a crosstab or using graph plays or whatever you do to kind of customize a figure in Stata. It's free, so it should work on every system. You should be able to download it anywhere as long as you have internet or have a copy of it. Be able to install on any machine, and almost every package works across all the 3 main operating systems. So the real big lore of R is not the thing you download off that website. It's really these add-on packages, this add-on software that the community builds. So there's over 10,000 packages that do things. So if you've looked into kind of learning R, some of the big ones you probably heard, ggplot2, dplyr, Knitter, and R Markdown. Some of these were written by people in the community. And if you've looked into R at all, there's this guy, Hadley Wickham, who's written a lot of them. And we'll talk about that, about kind of how to trust those packages, because those packages are written by people like me. And I would say, in some respects, they're written by sometimes statisticians, which is not always as a statistician, not always the best programming. So, so it's built on this entire infrastructure, and I think a lot of users who come from SAS or Stata are really kind of concerned about that. And what I usually say is, I don't know a single Stata user that doesn't download stuff from Boston BE Code, right? That builds add-on packages. And I don't know a single SAS user that doesn't use add-on macros that usually were written by somebody else. So usually it's always trusting other people's code. In some instances, you know that person, you can ask that person. But in some respects, you don't always have to do some vetting, but every package isn't made the same in R. So if it's a well-tested package, thousands of users use it, I usually trust that over something where it's a relatively narrow statistical method that I've seen like maybe one paper publish it. So it's designed for statistical computing, so you can do all the fun things, linear mixed effects models, generalized linear mixed effects models, standard GLMs, LMs, some hierarchical stuff. There's some other things that have been incorporated in this package called STAN, which can do Bayesian inference and all that kind of stuff. So the thing that's this kind of paradox is the more and more I've been in R, the more and more tutorials and things online said learn R in like a day, and it seems like a deluge of things coming down, and for new users it just seems too much. It's not focused, it's not localized, so it's kind of hard from what I've been hearing to kind of learn R off the ground. So that's why we kind of created this course many years ago. It's also kind of programming oriented and kind of a minimal interface. That has changed, the minimal interface part. So I had you download RStudio, and we'll get into that. But before, it was just this. Here, I think I still have it. So just R app. So this is like new and improved, but it was just like this. Like, this is R, go. And so for a new user, that wasn't very nice. And this is like light years ahead of what it used to be. And those who have a Windows machine, if you look at the native R that you downloaded, it is significantly worse. It's just, there wasn't a lot of stuff going into making it visually pleasing or organizing things in a good way. So that's changed dramatically in the last few years. So it's also, there's little kind of centralized support. So Stata, if something goes really wrong, or you have, dependent on your license or something, you can call them, or you can look at the help files or SAS, you can kind of write them and they'll write back. They have people to do that. Because it's a community, you can't really do that. And also, because it relies on this multitude of packages, right? Package A and package B may not work well together. They may have two different people who wrote them, so they have to talk to each other, or get them to work, or this person has to get this to work because this person changed something. And so it's just a little bit more of a community-oriented thing. But Stack Overflow and a lot of the other websites that have come out, not come out recently, but really that's where a lot of the help occurs. So it's not centralized on like Stata's website or anything like that. And like I said before, because you can do something like 10 different ways, you get a multitude of different answers that approach the problem in very different ways. So sometimes it is annoying to update. So when they go through a major version change, so I think everyone should have 3.4.1 or 3.4.0, depending on when you updated. When they go to, for example, a version 3.5 or a major version 4.0, some things can be a little bit annoying to say, oh, I wanted all my packages updated. You have to do some little manual stuff still, but that's changing. So the biggest gripe that a lot of people have is it holds your data completely in memory. So if you have a 20 gig data set, and you want to load the whole thing in R, you have to have 20 gigs of memory available on your machine. That is a problem. That is a large problem, for example, with people who do genomics. Most of the time, though, those people have access to a computing cluster, so that's not as big of a problem. There are some add-on packages that allow you to do operations on stuff that are on your hard disk. So if you have a 20 gig file, it'll read something like a data set in, but it doesn't actually load the whole thing up. It queries it kind of on the fly. Also, I'm a statistician. You can use sampling and get kind of a gist of what you need to do. You can subsample your data. A lot of times when you have a 20 gig file, you don't need that whole data set in. Usually it's either a whole bunch of rows and a whole bunch of columns. That's how it usually gets that big. A lot of times you don't need 10,000 variables in a data set. When you're doing some of these huge machine learning stuff, maybe. But I've seen some of the DHS data, and I know it has a lot of variables, but a lot of times in the analyses, you're not using all of them. Or if you're doing something, for example, at a country level, you might summarize the data at a country level or subset the data at a country level and then aggregate the multiple countries together if you're doing a full analysis. So, really briefly, I want to kind of gauge the class because I know this is a very different subset than the last class because the last class was like, I want to learn how to do a forest plot, and I was like, someone was like, I want to learn how to analyze microarrays, and I was like, those are very different. So really what I'm focusing on right now is you kind of have tabular data, spreadsheet type data, right? Rows and columns that are, we're not talking about images, we're not talking about, maps necessarily. We can talk about them if that's something you really, really want to hammer on. But you're not reading in like JPEG images and converting them or anything like that. So I'll give you a brief rundown of what we will cover, and then kind of want to pose the question, what else is like really burning? So we're going to talk about visualization. We're going to talk about basic summary statistics and modeling. We're not going to go too deep into, this is the right model or this is the, none of the statistical theory behind all that kind of stuff. We're going to talk about data reading, writing. We're going to talk about data manipulation, right? So subsetting, grouping data together, and summarizing data like that. We're going to be talking about making tables and, writing data out. So, and I mean writing data out in R data formats so that you can read them in later, or writing data out to CSVs or tabular formats that you use, maybe, for example, Excel to kind of pretty it up to make tables. So, and visualization. We're going to be plotting data, obviously. So is anything far out, like I want to learn how to do this? So I will also give an example. I downloaded some DHS data today. I will show you how to read in a DTA from DHS, one of the DHS files, and parse one of the do files that does the variable labeling for that. So you have a data set that has all the labels on there, right? So it doesn't say 1 or 0 for male and female. It actually says the word male, it says the word female. And it will have an associated data set. They're not going to be kind of blended together. They are like in Stata, where you double click it and it says this variable is this question, for example. It'll be this data set's over here. This data set is kind of the labels for each variable. So we are going to show that as well. Because I think that was the one thing we said was we definitely needed to do. All right. Okay, so the course website. So my website is just my name.com. So if you go there and you forget where the website is, it's like the first link. It says like teaching and it says like introduction to R. It says the materials we uploaded the night before class. They're all uploaded, but I might do some updates. They should have an HTML and a PDF associated with each one of them if you want to download and annotate them. I will be, hopefully, I think my voice carries pretty well. I screen record everything I'm doing, and I'll upload it to YouTube. So, for example, if I know some people had to duck out early or come in late or something like that. So if you do miss like the first half hour or miss an hour or miss a day, it should be on YouTube the next day, so you can kind of scroll through and go through that if you want. And also the last 2 weeks ago, all those YouTubes are up there, and these are relatively the same slide decks. Okay, so yeah, reading data, recoding, manipulating data. We're not going to get too much into writing R functions, but we're definitely going to use add-on packages a lot, making exploratory plots like scatter plots, histograms, box plots, fun scatter plots with smoothers through them, and then plots with what I call facets. So you break out the same plot, for let's say 3 different subgroups, and all the axes are constrained to be the same, right? The x-axis and the y-axis are the exact same. Understand some of the basic programming syntax, and we're going to talk about basic statistical tests. Again, we're going to get into the overall syntax, but specific stuff we're not going to go into. We'll cover, for example, t-tests, Wilcox and rank sum, correlation tests, kind of visualizing some of that stuff, and limit models. So this is the format. So we can kind of play this by ear because I think this subset, your group, is much higher technical skill than I would say the average I've had in the past. I mean, most of you have done some stuff with Stata at least, right? So you've done some data manipulation. I would say you understand what a computer is, or some students do. I mean, you understand what I mean by working directory in some respects, right? So so that was kind of So that is a bar that is very hard to teach, but once you're there, it's much easier to teach to that. So we might move a little bit faster than some of the previous classes, but if I am ever going too fast, don't hesitate to stop me. And we're gonna have some labs and kind of go over those. Grading, I don't know. I think 2 people are taking this. 1 maybe for a grade, but there's homeworks. Just email them to me, the R files. I think my predecessor or my co-instructor made these breakdowns. So we're going to have a final project, but the final project really is kind of reading a data set, doing some data manipulation, some summarizations, doing some tables out, and then getting plots in kind of one whole area. And one of the reasons I might go a bit faster than others is because the last term, or the last 2 weeks ago, we did not cover knitr and R Markdown, which I think is a really, really powerful tool, especially for a group like yours, where you can do reports, where you inlay kind of figures, prose, and text, and within the text you can inject like summary statistics and stuff like that. So you say, for example, the mean of the group was, and you write some R specific syntax, and then you say blank years, and then when you compile that together, it'll say the mean of the group was 35 years old, right? So it'll inlay so when you update that data set, for example, and the mean is like 39 years old, that report will now say 39 instead of 35. So again, due dates are, as long as it's, I pretty much posted all the keys to it. I find it, if you're just going and looking at the keys, you're not going to really take a lot from this class. So all the keys are there, but so the due dates are pretty flexible, just before kind of grades are due. So when the final project, so if you're kind of struggling along but you want to do them, they will still be, the keys will still be posted. I mean, it is very clear though when you just take the same key, right? Like I wrote that key. So, but it's pretty flexible with respect to grading. But if you want to say don't post the keys until I'm done, I will do that. But I found it helps to kind of just post the keys regardless, especially because the majority of the class is not taken for credit. All right. So everybody has R and RStudio installed. Yes. All right. Okay, so I talked about these two, TryR and CodeSchool. These are other really good resources. I think if you've Googled enough, the UCLA website for example analyses is tremendous. It shows you all three of the main languages, how to do things. That is also still true for R. There's a short reference card that kind of says these are like kind of a lot of the main functions you're going to use. Excuse me. There's an underground guide to R. And QuickR. QuickR is really good for showing you how to do, like, I want to do this specific type of plot in R. It has a really good set of like tutorials that say, you want to do this plot, go to this. Or these are the exact commands you'd use. And lastly, I'm going to go to the website, and we're going to talk about some of the things on there. So don't concern yourself yet with this PDF. The reason that is kind of up there, when we get to visualization, sometimes, at least the projector I was using in the previous course, didn't show some of the like what I saw on my screen wasn't shown on the projector. So some of the visualizations I might put up a PDF so you can see the difference. I don't know if it's going to do the same thing with a monitor. So the syllabus is located here. Again, the lectures from the previous week. The big thing, and this was a kind of a sticking point in the last class. So what we're going to do now, we are going to use a set of packages, so a set of add-on functions throughout this course. So what I want you to do now is to click on this text file. So this should bring up, these are all the packages that we will use at all in this course. So what I want you to do is download that text file right now. So if usually you can say file save as, for example, if you're in Safari, if it doesn't download automatically, because we're going to just download another script, open it in R, and it's going to install all these packages for us so that we don't have to kind of go through that process, because sometimes a student will be running code, for example, and they say, well, this doesn't work, and it's because this package hasn't been installed or loaded up. Okay, so let's save this down. Okay, I'm going to say all the packages. I'm going to download to my desktop. I'm going to close that out. Back to the website. So it's right under packages. And then, secondly, there should say a file that says run this R script. So I'm going to click on that. It's a really simple script. So we downloaded this text file, all the packages.txt, and all this is going to do is read that in and then install them all. So if you download this as well, let's say save as, and you got to put it in the same exact place. For some reason though, Safari and some other systems might try to put a .txt at the end. Just save it as a .r file. And then if you go to where it was downloaded, so if you have those two downloaded, just double click the R file. Nope, it doesn't run it. It's never run it when R has done this, but if you've worked in Stata long enough, you know the old way, Stata used to do files automatically. I don't think it does that anymore. I think it just pops them up because that was annoying and it wasn't very helpful. So now if you just take these two commands, and we're gonna walk through the RStudio console and all that kind of stuff. This might open in your native R app, but if you highlight the two lines of text, and you can either copy them over to the console over here and hit run and just hit enter, it will run them. I'm not going to run them because I have all these installed. So if you copy them over to the console, for example, just copy the lines of that text and run it. It should execute some sort of command.
Sorry, can you back up this?
Yes.
I'm trying to open it in R, but I can't find it on the list of programs.
So RStudio, yeah. There you go. Yes.
Error message.
Error message. So,
Do we have to change the directory? The directory.
Yeah, so let's, if it opens in the native R app, so close that out. Yeah, so, You should, yeah. So that's what we're gonna do. I'm gonna. Okay, good question. I don't know how to do it for Windows just yet, but I will do that in a second. So what we want to do is associate our files with RStudio rather than R. So for example, if you go to that file and you right click, you click get info for those on Macs. It might say, for example, down here, open with. So it should pop up this little window, and you say open with. What you should click is go down and click RStudio if it's not the default, and then hit this button change all. So on Windows, okay. So you have to. So wherever the file is located, yep, right click it. Get info. We're going to associate, opens with. And then hit RStudio. You have to do other. So you hit App Store, so just close that. Just other here. Yes.
First one?
RStudio. Where you downloaded that.
Wait, did I not?
Okay, yeah, so you have to download RStudio.
Oh,
Yeah.
Wait, okay. That's.
That's the first one. And then the next part of the
This one?
exactly. So download that.
So I need both?
Yes.
Okay, I see.
So you should be able to. Oh no. So where's the file you download?
I saved it actually.
Where'd you save it?
Save it.
So right click. You have to name it all the packages. You have to name it the name of that it was on the website.
I mean,
So file, save as. You should be able to do Command S. Click off. Save. I don't think it's here. Okay. So here, go back. Just go back to the website window, and then go back one. Hit right click. And hit save. Save targets. Okay, so let's save that. Let's save that in documents for now. It's okay. Yep. Save. Right click the script. Save as. And then save it there. You can so open folder. Yeah, so install packages. So let's double click that. Let's hit open with. Yeah, open with and associate with RStudio. Perfect. And then it should pop up. And you can click, if you open it the way we just said, you can click this run command and it should run it.
So you have to highlight the script before you.
You don't have to. I just if you copy and paste, if you don't highlight anything, click run. It'll just run the whole thing.
Only if I highlight it.
Or you can click source. That is the. Actually, sorry. Run will run a specific line. We'll do line by line. Yes.
It's red, but it's down.
So this. Yeah. So you did you save it in the same place?
Yeah.
Yeah.
Oh, I mean,
Okay. So
with ours like we do?
this wasn't saved. This isn't saved as a text file.
Yes.
It's a little Safari. So okay. So let's just write it inside. Save. Download these files. And let's go back to RStudio. Yeah, let's go back here. Just like that. Yep.
No.
All in RStudio.
It was right.
saying.
This is again.
Okay.
I guess
Bring chase them all.
That's
Now,
not-
you open it. Should open RStudio.
But I
And then you should just click source.
Okay.
Alright, so that should be running.
That's running.
Is it running?
You're running.
Alright.
It's good. So you're downloading
think it
stuff.
must treat.
Downloading
So
stuff.
the reason is because
Yeah.
I can save that as a.
It's not our, it's down there.
Alright, so downloading.
Get back.
I didn't know you had to open it from there. Did you download this one? Okay.
No, they have,
Okay.
they have their own,
Yeah.
each computer has their own.
So you go to the stage.
So what's the difference between R and RStudio then?
That's what we're gonna get to right now.
Right.
I think you might need to reopen.
This one, no, this stage. You want to
Yeah.
send this to them? This first.
Try,
Yeah.
Yeah, it takes a little while to download and compile some of these, so that's why we just go.
Yeah. Yeah, document, you can save it. And then you go back
Here, so,
I
yeah,
have it.
let's just close this out,
here. And then you go back.
and then we're just gonna
That's
files. Okay.
And then you go there and download it or save it.
Install package, just open like that,
You did? That's a problem.
and then just click source.
Yeah.
That should be right. All right. So what is the difference between R and RStudio? That's a big question. So R itself, so there's kind of three things I'll be talking about. There's the R application, R itself, which is like the language and the interpreter and all that kind of stuff. And then there's RStudio, which is the thing we downloaded on top of it. And the reason we downloaded it is to make things easier it just makes a lot of things in R easier. And we'll get to exactly what I mean by that. So the console is kind of whatever you type, right? So in Stata, for example, you have a command line, same thing as an R console. It's a place you can do things interactive. SAS doesn't really have something like that. Doesn't have like a line where you just do some interactive things and then you do things. In a script, it kind of says everything in a script. Then you have to put run, and you have to run it, right? So it's somewhat similar to Stata in that regard. I will say though that the syntax for an R script and the syntax for the R console are exactly the same. Whereas in Stata, if you have, for example, a multi-line command where you have those 3 slashes and you copy that into the console, into the command line, things can go wrong and it doesn't like that. That's not the case here, right? So just a calculator, you can create variables. And when I say, I'm going to say this kind of interchangeably throughout the course, variables and objects, right? So when I say variables, unless I say, columns of a data set or variables of this data set, I do not mean like predictors and that kind of stuff or something in a rectangular format. I mean just a thing R sees. So I'll call them variables or objects, and we'll dig into those a little bit deeper. For example, a variable or an object can be a data set, it can be a model, it can be a table, it can be a plot. It's just something that's stored in R's environment, in your history, in your memory. Right, so we'll talk about those and those in a lot more detail. But when I say variable, I don't mean a column of a data set. And you can do a lot of interactive things in the console. That's pretty much where you do kind of your exploring, viewing, a column or something like that to see if something's off. But in the script, it's where you put all your code. You can try things out interactively in your script, so you can highlight things and then send them over to the console like I was showing you, right? You can highlight things and then click run and it'll run it over in the console, just like you would in a do file, for example. But again, reproducibility, which I don't think is spelled right. You pretty much want to do, if you're doing anything to a data set, you want to encode, right? Unless it's something that's, if it's raw, unless it's raw data, I don't pretty much trust anything until raw to final product. Everything has to be documented, scripted, done in a script, right? Whether how well it's documented, that's always a matter of debate. But if it's not done in code, if you said, oh, I looked at this and then we changed like 4 values and I don't know which 4 values you changed, that's not really good. I remember a few years ago we had a collaboration where someone said, oh, well, we had missing data in this column, and so we imputed the mean. And then we said, well, which ones were imputed? They said, well, we don't know. And then I said, well, I hope you have a backup. And they said, well, no, we don't, but it's fine. And we're like, that's not fine. And then it took like, they were like, oh, well, we found one in an email from like 6 months ago. And it looks similar. We're like, okay. So data management. All right. So again, it's essentially a command line with a set of functions loaded up. So just like Stata, it's got sort, like Stata's got sort loaded up, use, merge, all those kind of commands loaded up by default. It also has all the functions you have in the ADO files that you've loaded from BE code or wherever like that. R from its core has a set of functions. Those set of functions are what we call base R. They are the base packages. So when you download R, you download this application, the one I said is not too pretty and not too intuitive, and you download all the scripts, all the actual code that makes R run, and all the functions that are saying like, this is what R is. This is the very basic bare bones of R. For example, it's like sorting vectors, the linear like the stats packages in there for linear models and generalized linear models, stuff like that. Utilities to find file paths and stuff like that. That is at its core what you download off that website. Everything else that you do relies on, if you want functions, additional functions, you download them or you load them from other packages or libraries. So R itself is just a simple collection of functions, right? The R app is just a really ugly thing that we're never going to use, but that also gets downloaded. Again, all it does is take input, perform computations, or some sort of manipulation of data and returns results at its basics. Again, functions are enclosed in packages. So if you've ever worked in a system like MATLAB, for example, there is like a website where you download specific functions for certain things. That's not how really R operates. You wouldn't download, for example, you might, but you usually don't download someone's like script and then you run that and you run all your commands. You run a whole package that encapsulates multiple functions that have interplay functionality and stuff like that. So for example, like a plotting library or a data manipulation library, one of them that we're going to use heavily is called dplyr, that has a lot of data manipulation commands. Again, some are bad. Some people aren't good programmers. Some people are sloppy programmers. Some people program something for their thesis and then their advisor said, you need to get this out on the market because you're about to leave in 2 weeks and somebody's going to ask for this and I have no idea what it does. Get it out there, and then they leave and they never maintain it. Some of them are bad. So there are some ways, we're going to talk about how to trust some of them, but you can think of them as R extensions, right? So the reason we talk about this base R, so I kind of think of base R as the old school way of doing things, or the older way of doing things in some respects, because I would say what we're going to teach you is not a lot of the ways I was taught to do things in R. And the reason for that is they are blindly unintuitive. But the reason we might shed light on some of those in this course is because when you look for answers online, on Stack Overflow or something like that, a lot of the people answering those questions have been using R for 20 years, and they don't use some of these newer ways, and they use slightly different syntax. So we want you to at least be aware of it. So RStudio is the thing you downloaded on your computer. It is an IDE, Integrated Development Environment. It's a way that kind of has your code, your plots, your help, all in kind of one place. It allows you to do syntax highlighting. That will allow you to say like, hey, like you missed a quote here, or you missed a parentheses here, or something like that, or your indentation's not really good. You might want to reformat your code because it's really hard to read. RStudio is also the name of its company that makes it. So RStudio is a company that employs people. Those people make a product called RStudio. So Hadley Wickham is one of those employees. So he's written many, many, many packages, and that is his full-time job. His packages are good. They're well vetted, well documented. His help files to a new user are very confusing, I will say. It's for certain of his packages. But if you see something written by him or the folks at RStudio, that is a general, usually, unless they say this is a very new package, that use it at your own risk, it is a very well-documented, well-developed package, well-tested. So Jeff Leake, also in our department, wrote a blog post about this on how to kind of trust an R package. There are some websites where you can look at the popularity of packages, for example, and something that's used by 10. So, for example, they track the number of downloads. So, if something has a huge number of downloads, it's usually one of two things: a really, really useful package, or it's really pivotal to a larger set of packages. So, for example, somebody made a really good package that you might not use on the day-to-day, but a lot of the packages that you do use, a lot of them rely on this one. So those are two good ways to kind of see how good a package is, the number of downloads, and kind of who develops it. And there is a whole other team, other than Hadley Wickham, at RStudio that does development. So they have a lot of packages out there. There's something you might see online, which we're going to use a lot. They call it the Tidyverse. They used to call it the Hadleyverse because he had so many packages. It was kind of a universe, a whole different way of thinking in R that he and some others had developed, and we're going to use those packages. So, for example, when I talk about dplyr, string R, ggplot2, he was the main creator behind those. Oop. Okay, so why don't we use RStudio? I think it helps the user, it makes things easier. What it is not a system that allows you to do drop-down analyses. So Stata's got a really good system that, people get paid, a lot of people get paid to develop. A drop-down system that says, I want to do longitudinal data analysis and I want to do panel data, and then it builds up a GUI and it says, what's the ID variable, what's the time variable, what's the origin, all that kind of stuff, and you click and point, and at the end of the day, you have a great, XT set, and you can do your XT mixed models. That is not what RStudio is, okay? There are, I would say, probably two systems that try to do that. One's called R Commander and one's called Radiant. They are in no way to the order of what Stata has. So RStudio allows you to write code and do analyses easier and kind of organize things in a really good way, but it is not a system that allows you to do drop-down kind of analyses and picking like, this is my Y variable, this is my X variables. So yeah. So one of the big things in when you're writing code, it allows for good syntax highlighting, code completion, which we're going to be talking about. So let's say you have a variable and you're like, what is that called? I mean, is it like age _ at consent? I don't really remember. So some of these commands you can hit tab, for example, and it'll say these are the variables in this data set that you're using. Which one do you want to pick out? And you hit tab, and you highlight the one, and it does tab completion. Stata does that, but only at the command line, right? After you do a unique string, right? So if you had 3 variables that said age, once you got to a unique string that was like age _ something, if nothing else was age _ and you hit tab, it would complete it. But it doesn't do that in the do file editor, I don't believe yet. So I'll show you exactly what I mean later, and it does some smart indentation so you can actually read the code you write. And it easily manages multiple working directories and projects. We will talk about this thing called RStudio projects, so that when you can have multiple RStudios up. This RStudio can have data from this study. This one can have a different study. None of them talk to each other, and they all are automatically set to the working directory that you need to be in. So it has some more information. I'm going to touch lightly on some of these because I don't use them that much. You might find them a lot more intuitive or helpful. But again, I was kind of growing up on R before RStudio existed, so I'm used to just literally a command line and a text editor side by side. But there's a workspace browser and a data viewer. So the data viewer, I don't use it as heavily, but I will try to use it more because it's very similar to browse or edit in Stata. Plot history, so you can scroll through the previous plots you've done. It saves history of them. Zooming, so the plot window in RStudio is pretty small, so you can zoom it out, stretch it just to kind of see what it looks like. Image and PDF export, that exists. We're not going to use that because we're going to show how to do exporting and saving graphs programmatically in our Connolly graph export in Stata. So help and documentation and a searchable command history. So all the commands you've done in this current session, you can kind of scroll through them. If you've done a lot of things interactively, then you can highlight all that and then say, make me an R script out of the things I did. It's not exactly like command history in Stata. It doesn't only keep commands that worked, it keeps the commands that worked or didn't work and all that kind of stuff. All right. So the console, I showed you it before, and one thing I want to note, your RStudio will undoubtedly not look like my RStudio. My RStudio has a black background, white text. That's the way I do it. So if you're on a Mac, you can go to RStudio Preferences. If you're on Windows, I believe if you go to Tools, Global Options, or Project Options, you should be able to see the same screen. You might not be on the same tab, but you should be able to see this. Is that correct? Okay. All right. So either Tools, Global Options for everyone, and then it's got a couple. So Tool, Global Options, and this is what should come up. So it's got a lot of different options going on here. These are for RStudio, not R. So this is all about kind of the appearance, layout, and all that kind of stuff of RStudio. The one main thing I want to show, pane layout. So the way I work, my scripts are on the left. The console's on the right. So that's why I put source up here, console on the right, and then I split things kind of haphazardly, environment, all these other things are kind of on the left-hand side, these are on the right-hand side. You can kind of keep what you like or whichever way you want. Some people really like the top to be the script, the bottom to be code. So you can change that layout however you want. And I will say you want to look at plain layout and appearance. So the editor font, I believe this is the default font in Mac. I will say I don't believe this font is default installed on Windows, so I don't think you can use Monaco. But I do remember the default font in Windows is not particularly good at differentiating, like, I forget which letters. It was, like an L and an I. It wasn't particularly set in a way that really let you see kind of lowercase O's and uppercase O's were not very clearly delineated. So you might want to change around some of the fonts, and then, for example, change any of these editor themes. I have no idea what mine is. Mine is Tomorrow Night Bright. So yeah, so that's the one I chose one day, and it gives you kind of a gist as to how it will look. So it shows you curly braces are a little bluish, quotes around strings are yellow, certain special words such as null are, in like a salmon color, certain other special words like function are in purple. So whatever makes the most sense to your eyes, use that one. Because really, it seems trivial, but that really can help, especially when you do make some slight errors in your code. Your brain is really good at picking up visual patterns, so use it as much as you can. All right, so console is where you can do things interactively, right? So kind of like it's exactly like the Stata command line. The script you can always, it's where code's executed. You can type things here interactively. It's not saved to your disk. Right? So this is just stuff you're playing around with. There is a history. I will not say to rely on that history. That history can be deleted. It gets deleted after so many thousand lines or something like that. We've talked about how to change the layout, make it set up to however you like. You cannot break the panes up. You cannot separate the windows out. That is either a good or bad thing. I personally don't like the fact that on a Mac, things are just not connected in the same way. I can't bound them together. But on the flip side, if you like that versatility, you can't do that here. The script. So this is where you type all your commands, all your comments, all that kind of stuff that you'd actually have code. You can, like we showed before, type commands up here, highlight them, and interactively just throw them down here. You don't have to copy and paste, right? Just like you would do in Stata, you could do or I forget what the other. I think there's a run and a do. I don't know. It's like run this line or whatever, like I forget. But So it's totally fine to just write commands up here and then interactively put them down here as long as you want to save them. Big things. This is where files open to. You can have R code and comments in them. You highlight, and on a Mac, if you highlight them and write command or hit Command Enter, they execute. Control Enter on Windows, and you just run the highlighted code. It will also do line advancement. So if I don't highlight anything, and I say like comment 1, that's not this. Sorry about that. This little thing's a little fidgety.